All right, so we're going to be talking about angles. We're going to name angles, and we're going to classify angles, and we're going to talk about different pairs of angles also. So firstly, an angle is the figure formed by two rays that have the same endpoint. So if you remember last time, rays start at one point and they go through another point. The two rays are called the sides of the angle, super creative there. And the endpoint is called the vertex of the angle. The shared endpoint is the vertex of the angle. So if we have some two rays that share an endpoint, so let's say this is ray AB, and we have another ray coming out here. Let's say ray AC. Remember that cannot name these anything different because the rays have to start with the endpoint and go through another point. So ray AB and ray AC make angle BAC. We can also call it angle, actually let's do this. We can also call it angle CAB. This is a sloppy symbol. So there's two symbols that mean angle. One, it's not a less than symbol, it looks like it, but this bottom line is flat. And then the other side goes up. That's one way to say angle. The other way is to have just an angle, a less than symbol, with a line through the more angular part of it. So of the angle, this angle CAB or BAC, they both reference this angle. This is a side, and this is a side, and this is the vertex of the angle. So that's pretty much it. The important part is that when you name an angle, the middle letter has to be the vertex point. I cannot call this angle ABC. If I was talking about angle ABC, it would go from A, B would be the vertex, and then it would go through C. That would be angle ABC. But we're talking about angle BAC or CAB. In each way we name it, A has to be the vertex. It has to be. So that's probably more in depth talking about angles than you've ever talked about before. So I'm sure you know about acute angles. So an acute angle has a measure less than 90 degrees. So let's get a protractor in here. And so we can have any angle. Let's see if I can. There it is. That's an acute angle. That's an acute angle. That's an acute angle. And that's an acute angle because it's 89 degrees. As long as it's less than 90, it's an acute angle. So we're good with that. So any angle that I drew in here that's less than 90 degrees, this where we have a side starting on the right side of the protractor, and the other side is still on the right side of the protractor, that's going to be an acute angle. No matter what angle I draw in there, it's always going to be acute. So let's get another protractor in here for a right angle. There's only one right angle that I can draw, and it is going to be 90 degrees. That is the only right angle. More often than not, when we draw a right angle, we can notate it by putting a box in close to the vertex of the angle. So we don't even have to write this. If that's a box, it's a right angle. We know that. That's it. And I might be able to draw. Oops. That. I can draw another 90-degree angle. Although this is a silly program, it measured this angle out here instead of this angle. Still a 90-degree angle. So these are both right angles. Thirdly, we have an obtuse angle. So if we get another protractor, I'm actually going to shrink it a little bit. Any angle that is bigger than 90 degrees. So if I measure this angle, that's 175, that's an obtuse angle. I just did another obtuse angle. Make it a little smaller, still obtuse. Make it a little smaller, still obtuse. Make it a little smaller, still obtuse. I can make it up to right there. This is a 91 degree angle. 91 degrees is still an obtuse angle because it's bigger than 90 degrees. So as long as it's between 90 and 180 degrees, between them, it cannot be 90, it cannot be 180. It has to be between them. That's an obtuse angle. Fourthly is a straight angle. And there's only one angle that I can draw that is a straight angle, and that angle is a line. A line is technically a straight angle. Its angle measure is 180 degrees. As long as I have a vertex and two rays going in either direction, in fact, two opposite rays will always make a straight angle. So that's four types of angles: acute, right, obtuse, and straight. Acute is less than 90 degrees. A right is 90 degrees. An obtuse is between 90 and 180. And a straight angle is exactly 180 degrees. The protractor postulate, this is a whole lot of words. I want you to copy it down. But what the protractor postulate says, it's very similar to the ruler postulate, where the ruler postulate is a way to set up a number line where any points 0 and 1, you can set them however far apart you want and it works. The protractor postulate is a little bit stricter. So what it's saying is that, so we have line AB. We should start with that. So here's a line. I'm going to put some points on it. Point A and point B. Good. I want to choose any point O that is between A and B. So I'm going to put a point right in the middle. It doesn't have to be in the middle, but I want it to be. Makes it a little bit simpler. Between A and B. So we're considering rays OA and ray OB. And all of the rays that can be drawn from O on one side of line AB. So I want to be able to draw any ray that I want on one side of line AB. So I can draw as many different rays as I want. But I'm just going to consider them, so I'm considering ray OA, ray OB, and all the rays that can be drawn on one side of line AB. These rays can be paired with the real numbers from 0 to 180. That is the protractor. So we're talking about this side. That's going to be our protractor. What it's saying is that we can pair, if we drew 180 rays coming out of O, as long as they're evenly spaced, we can pair these rays in such a way that OA is paired with 0. No. OA is going to be paired with 0, and OB is going to be paired with 180. And everything else in between is one of the angles on a protractor. Now, A doesn't have to be over there, and B doesn't have to be over here. If we switched it, it would still work out. And when you look at a protractor, that's why there's two scales on it. There's an inside scale and an outside scale. Because maybe 0 is on this side, or maybe 0 is on this side. It doesn't really matter. Similarly, if we have some angle, let's call this angle X and this angle Y. So we have this angle X and that angle Y. So from OA to this line here, that's going to be angle Y, and this is going to be angle X. So we can actually find this angle in here by taking the difference of X and Y. So essentially, if I have this whole pie piece here, and I subtract Y, this is what I'm left with. OP, so let's put point P up here, and put point Q over here. Nope, I did that backwards. Because OP is paired with X, and OQ is paired with Y, So the measure of angle, POQ, is the absolute value of the difference of the angles. And all that's saying, first of all, an angle measure can't be negative, so that's why it has the absolute value. This taking angle X minus angle Y is taking this whole angle and subtracting the part that is Y, and you're left with just the measure of angle POQ. And that's really all the protractor postulate says. It talks about how to set up a protractor, and it talks about how to get angle measures from two given angles. In this case, angles X and Y. The angle addition postulate is kind of the converse of that, like this, but the protractor postulate, but backwards. What this is saying is if you have the measure of some angle AOB, so this is AOB, and the measure of angle BOC. So if we take the measure of angle AOB plus the measure of BOC, then the angle of the sum will be this total measure of AOC. Which, I mean, that makes sense, because if I have two things that are right next to each other and I add them together, I get the whole thing. That's what addition does. There's more about it, is that if AOC is a straight angle, so let's say this is angle AOC, if that's a straight angle, and I have B somewhere up here, then I don't care what the measures are, the measure of this angle plus the measure of that angle will give us 180 degrees, always. Because AOC has to be a straight angle. A couple more definitions. Congruent angles are angles that have equal measures. Their measures are equal, the angles are congruent. So that's the difference between the two words. Congruent and equal both mean the same, but if you're talking about geometric shapes, they're congruent. If you're talking about numbers, they're equal. So their measures are equal, but the angles themselves are congruent. Adjacent angles are two angles in a plane that have a common vertex and a common side, but no common interior points. So that's a lot of words. Let's try and draw a picture. So let's say we have something like this, and we have angle AOB and angle BOC. So adjacent angles. So we can say that angle AOB is adjacent to angle BOC because they have a common vertex and a common side. They both share vertex O and they both share side OB. But they don't share any interior points. Now, what does interior points mean? Well, let's look at angle AOC and angle BOC. In this case, they both share vertex O and they both share side OC. So they both share a vertex and they both share a common side. But this is where the common interior points happens, is that point B is inside angle AOC. And that can't happen. So angle AOC and angle BOC are not going to be adjacent because they share this inside point. Or I should say this point is inside the bigger angle. So if you have a point, if you have a part of one angle inside the other angle, they are not adjacent angles. One is just on the interior of the other one. Lastly, vertical angles are formed, vertical angles are opposite angles formed by two intersecting lines, rays, or segments. So I can draw, let's see, I can draw any two lines. I'm going to use lines in this case. Let's give this some point names. We'll call them this point M, P, Q, R, and S. So we can say that angle PMS and angle QMR, those are vertical angles. Furthermore, SMR and PMQ are also going to be vertical angles. Vertical just means that we have two angles created by intersecting lines that are opposite each other. So like SMP and QMP, those are adjacent angles because they share this side and this vertex. They also create a straight angle. And so in a diagram like this, you have 4 pairs of adjacent angles and you have 2 pairs of vertical angles. And yeah, that's it. Now we're going to talk about complementary angles. Complementary angles are 2 angles whose sum is 90 degrees. So if I were to draw a right angle, I'm going to say, hey, this is a right angle. There's the right angle symbol. And I were to draw an extra angle in there, and let's say this is 60 degrees, and that's 30 degrees. Since 60 plus 30 is 90, these 2 angles are complementary angles. Now, kind of in the same idea of this, we can also talk about the complement of an angle. So if I have some angle, this angle, whose measure is 50 degrees, and I ask what is the complement of 50 degrees, the complement of 50 degrees is 40 degrees, because 40 plus 50 is 90. So that's the complement. How would I figure that out? I would just take 90 minus 50, and I get 40. It's the same as solving for x. So if I know that 2 angles added together is 90 degrees, I can say 50 degrees plus some angle measure is going to be 90, and I just solve for x. That's all. Just a little bit of algebra. Lastly, there's supplementary angles, which are 2 angles whose sum is 180 degrees. So if I have a straight angle here, and I split it into 2 angles, these 2 angles are going to be supplementary angles because their sum is 180 degrees. So maybe this is 70 degrees, and this is 110 degrees. 110 plus 70 is 180, so 110 and 70 are going to be supplementary angles. Also the same as the last one, maybe I have an angle measure or an angle like this whose measure is 80 degrees, and I ask, hey, what is the supplement of 80 degrees? Well, I'm going to solve it the exact same way, where I know one angle is 80 degrees, and I want to add some angle to that to get 180 degrees. Again, just a little bit of algebra tells me that 100 degrees is the supplement, not enough space. Is the supplement of 80 degrees. There you go. Angles and stuff.